Well, this video is for Math 70. I'm going to go over a sample midterm to give you an idea of what you can expect to see for our midterm next week. It follows along very closely with the assignments that we've been doing. Okay, so we'll start out. First off, we get two problems on simplification. First one is 2 minus 5 times 3x minus 1 plus 8 times x minus 4. So I mentioned this when we were doing this assignment, is don't fall for this right here. Okay, that's the most common mistake that people make on this problem. They want to do 2 minus 5 equals negative 3. Doesn't happen that way, okay? Order of operations says that this multiplication and this multiplication have to happen before we do the adding or subtracting, all right? So one way to look at this is that you've essentially got 3 pieces here, okay? And that 2 is an individual piece and won't be combined with anything else until we simplify these other 2 pieces. All right, so let's go ahead and simplify them by distributing into the parentheses. So the 2 stays the same. Then we do negative 5 times 3x minus 15x. Negative 5 times negative 1, positive 5. 8 times x is 8x. 8 times negative 4, negative 32. Okay, now we have all these individual pieces and we can combine like terms. So we've got an 8x and a minus 15x. That makes negative 7x. And then we have 2 plus 5 and minus 32. So the 2 and the 5 make 7. 7 minus 32 should be negative 25. And there's our answer right there. All right. Problem 2 is similar. Let's see what we've got here. 7 times 2x plus 3 minus 4 times 5x plus 1 plus 12. Okay, very similar approach, except here the 12 is in the back instead of being in the front. So we're going to distribute here, and then combine like terms. So we'll get 14x plus 21. And then minus 20x, minus 4, and positive 12. Okay, so there's minus 20x and positive 14x. That makes negative 6x. 21 minus 4 plus 12. So this will be 17. 21 minus 4, 17 plus 12. That will be positive 29. Okay. So that's it for the simplifying problems. Let's keep moving here. Problem 3 is a substitution problem. So problem 3 says, let's see, we've got z minus x all squared, and then yz minus x on the bottom, and plus xy on the side there. And we've got values for x, negative 2.57, y is 6.22, and z is negative 0.83. Okay, now I think it's a good idea to compute these things in pieces rather than trying to enter that into your calculator all at once. Okay, so that's how I'm going to approach this. So I'm going to calculate z minus x and then square it. So z minus x, well, z is negative 0.83 minus, so here's the thing, and I'll write this down. Negative 0.83 minus, and the x is negative 2.57. So I point this out whenever we see this. This minus sign comes from the formula, okay? This minus sign right here comes from the value of x. And so this is going to end up being 0.83 plus 2.57, or negative 0.83 plus 2.57, and that's going to give us 1.74. And so then if we square that, we get 3.0276. Okay. Now notice I didn't try to square these individually. We need to do what's inside the parentheses first and then apply the exponent to it. Okay. Now we want to do yz minus x. So y 6.22, z is negative 0.83, and then again this minus x we're going to have minus negative 2.57. So 6.22 times negative 0.83 is negative 5.1626, and then we're going to add 2.57 onto that. And that's going to be negative 2.5926. So far we've got 3.0276 over negative 2.5926, and then plus xy. So that's going to be negative 2.57 times 6.22. Negative 15.9854. And let's go ahead and divide this. 3.0276 divided by negative 2.5926. And so we can round this a little bit. Let's see, in the end we're going to round to the hundredths place, so we'll go a little bit past that. Negative 1 point, we'll call it 1678. Okay, and then we want to subtract 15.9854. So this is coming out to about negative 17, and to the nearest hundredth, 0.15. Okay, so you can do all of this calculation all at once on your calculator if that's what you choose to do. I think it's a better idea to do this in pieces. Okay, you're less likely to make a mistake and more able to catch a mistake if you've made one, if you're doing this in pieces. All right. Well, now I think we're going to look at some equation solving problems. Starting with number 4. Yeah. We've got 5 plus 3 times 2x minus 4 equals 9 times x plus 1 minus 7. So there's a bunch of things happening in this problem, in this equation. Number 1, again, you see this. All right, don't fall into that trap. You don't want to do 5 plus 3. What you need to do is multiply this 3 into the parentheses. Same thing over here. Okay, so this will be 5 plus 6x minus 12 equals 9x plus 9 minus 7. So if we combine our like terms on either side, let's see, negative 12 and positive 5 makes negative 7, and positive 9 minus 7 is positive 2. All right, so I'm going to move this 6x over with the 9x. I'm going to move the 2 over with the 7. So we're going to do minus 2 and minus 2. 6x minus 9 equals 9x. And then subtract the 6x. Negative 9 equals 3x. And so x will be negative 3. All right. Problem 5. What do we have here? 5/12 x plus 2/3 equals 7x minus 3/4. Okay. All right, so I'm going to approach this in exactly the same way I did that other problem. Okay, we're essentially at this step right here. I'm going to move this 3/4 over to be with the 2/3. That'll leave 7x here. And on the other side, we'll have the 5/12 x. And here we need to add 2/3 and 3/4. You're welcome to use the calculator on this one. I'll show you how to do it without the calculator. This one's going to be 8/12. This one's going to be 9/12. and so we'll end up with 17/12. And don't freak out because it's an improper fraction. There's nothing really improper about that. There's nothing wrong with that. Okay? We can just call it 17/12. If you want to call it 1 5/12, that's fine too. There's nothing wrong with that. All right. Now we're going to subtract this 5/12 x on both sides. That'll leave the 17/12 there. Over here, 7 minus 5/12, you can do this on the calculator or not. All right, what we're going to end up with here is 6 7/12, which is what, 79 over 12. 79 over 12. This is 17 over 12. And then divide on both sides by 79 over 12. I'm going to multiply by the reciprocal here. 12 over 79. Those 12s cancel. Here everything cancels. And we get x is equal to 17 over 79. Wow, well that's an interesting answer. I'm going to check this answer to make sure that it's correct. There's nothing wrong with it. It's just I don't recall setting up this problem to have that answer. So let's double check it. Let's see here. So we want to do, right, 5/12 times 17 over 79 plus 2/3. So let's see what we get there. I'm going to put these both in parentheses. 5 over 12, and then 17 over 79, and then plus 2/3. What do we get? This is 0.756329, and so on. Now the other side is going to be 7 times 17 over 79 minus 3/4. So 7 times 17 over 79 minus 3/4. Yep, same thing, 0.756329 ... Okay, so we get the same thing on both sides. That means this answer is right, even though I don't remember setting it up to be that answer. But that's okay. All right, let's keep going with these. We'll look at problem 6. All right, problem 6, another equation here. So, negative 0.60 times 15 minus 0.35 times x plus 2 equals 0.85x. All right, so let's simplify what we've got here, mostly on this side. This side we don't really need to do much to. But over here, what is that going to be? Is that going to be 9? Yeah, negative 9 here. And then minus 0.35x minus 0.7 equals 0.85x. All right, so this will be negative 9.7 minus 0.35x. And then, well, let me just pause here for a minute. Make sure we've got everything set up. Nothing happened over here, but I just did negative 9 minus 0.7 gives us negative 9.7. And then I'm going to add this 0.35x to both sides. So this will be negative 9.7, and this will be, what is this going to be, 1.2x. And so now I need to divide on both sides by 1.2. Let's see what we get here. Negative 9.7 divided by 1.2. And so x is going to be, what is this, negative 8.083 repeating. Okay, and we can turn that into a fraction if we want to. It's just 97 over 12, which is, I think that's 8 and 1/12. So anyway, any of those forms for your answer is fine. right? If you want to call this 97 over 12, that's fine. It's bad form to have decimals in your fraction, and so it is good to simplify if you're going to leave it as a fraction. Okay, let's look at problem 7. Now this is one of those cross-multiplying problems. We start out 7 over x plus 3 equals 2 over x. So we can cross multiply and say 7x equals 2 times x plus 3. And then we've got to distribute here 2x plus 6. And then move the 2x over here. That'll be 5x equals 6. And divide on both sides by 5. You can leave it as 6/5, or you can call it 1.2. They're both correct. Okay. All right, so that's it for the equations. Then we have a section on inequality. Problem 8. We've got 5x minus 7 less than or equal to negative 15. All right, so we'll add the 7 over here. And that'll be negative 8, right? Okay. And then we'll divide on both sides by 5. X is less than or equal to negative 8/5, or you can call this, what is this, negative 1.6. Okay, either way. And then we need to graph this on a number line. Here's our 0, here's negative 1.6, and we want all the x's that are less than that down in that direction. Okay. Let's see here. Problem 9. 2x plus 5 less than or equal to 10x plus 17. Okay, let's see here. Well, I'm going to move the 2x over to this side. Leave the 5 there. Then we'll have 8x plus 17. And then I'll move the 17 over here. 8x greater than or equal to 5 minus 17 is negative 12. Divide on both sides by 8. And this is going to be, looks like negative 1.5. Greater than or equal to. Okay. And then if we want to put this on the number line, again, very similar to that one, except in this case, the x is greater than negative 1.5. The colored in circle, and then all the numbers greater than negative 1.5. Okay. And remember, it points at whatever is smaller, right? This opening is larger, so the x has got to be bigger than that negative 1.5. Same thing over here. It's pointing at the x, and so the x's will be smaller than that negative 1.6. Alrighty, let's see here. Problem 10, we've got a compound inequality. 6 less than 5x minus 2 less than or equal to 15. Alright, so remember the key to these compound inequalities is that instead of doing things on both sides of the equation, here there are 3 sides. And so we have to add 2 in 3 different places. So this will be 5x less than or equal to 17, but greater than 8. And then the same thing with the 5. We're going to divide by 5 in 3 different places. So this will be x less than or equal to, looks like 3.4, but greater than 1.6. And don't worry about the fact that these are not whole numbers. There's nothing wrong with that. And I'm not asking you to be really detailed on your number lines. all we really need to do is put a 0 there, and then 3.4 is here, and we can put 1.6 there. This one gets an open circle because it's not equal to. This one gets a shaded circle because of that equals to on there. And then we want all the numbers in between there. Okay, so that's problem 10. Problem 11 is a pretty simple question, but you'll see one like this on the final exam, so I just wanted to make sure that you were ready for it. X greater than -6, so here's our -6, open circle, and all the numbers greater than that. Okay. All right, we're getting there. Let's see what we've got next here. The absolute value. Problem 12. We've got absolute value, 3x minus 4 equals 11. So the absolute value is already by itself, and so there's not anything that we have to do there. So the key step right now is to divide this in two pieces. 3x minus 4 equals 11. 3x minus 4 equals -11. All right, so now we just have to solve these two equations. Add 4, 3x is 15, x equals 5. Over here, add 4, 3x is -7, and here x is -7/3. Yeah, that's kind of funky looking there. Let's try that again. -7/3. And if you like decimals, then this would be -2.3 with the bar over the 3. Okay? So if you prefer decimals, I just ask that you use them appropriately, and if you've got a repeating decimal, just indicate that it's repeating. You know, you'll see it on the calculator. Just put a bar over the repeating part. All right, problem 13. This is one of those literal equations where we're solving for one variable in terms of the other variables. K equals m plus ay. So, and what are we solving for here? Solve for y. There we go. All right. So, we want to solve for the y right here. So that means we want to get the y, what has the y by itself. So, let's move the m to the other side. This will be k minus m equals ay. Now, the a is being multiplied by the y, and so we have to divide on both sides by a. So this is k minus m all over a. So that's an appropriate answer. If you wanted to divide them individually, you can write it like that. That's also correct. All right, both of these are correct answers for problem 13. Okay, well, we're coming up to the more recent assignments now. We've got a couple questions on graphing. So, problem 14, we've got this equation 5x minus 4y equals 16. Isolate the y variable, find 3 ordered pairs that satisfy the equation, and then graph the equation. Okay, so first we'll get the y by itself. Let's see here. So remember, this minus sign is attached to the 4y. This 5x is a positive 5x. So if I want to move it to the other side, I have to subtract. So then we get -4y equals -5x plus 16. And then here, this is a good place to divide individually. Okay? At least I find it helpful. You don't have to if you don't want to. So this will be positive 5/4 x minus 4. Now, I left it as a fraction because if I'm going to be plugging numbers in here, I'm going to pick numbers that are divisible by 4. All right? That'll give me whole numbers for my y's. So I'll use -4, 0, and 4. All right? So let's do 5/4 times negative 4. So that'll be negative 5 minus 4 is negative 9. 0 will just give us negative 4. And then positive 4 will give us 5 minus 4, which is 1. Okay. So, now don't forget when you go to graph to be sure to label your tick marks scale. That's what the technical word is. The scale for your graph. Okay, so let's see. Negative 4, negative 9 is down here. 0, negative 4 is right here. And positive 4, positive 1 is right there. So that makes a pretty good straight line, which says to me that my tick marks ended up pretty accurate. Okay. All right. So that's problem 14, and we've got one more of these, and then one problem after that. So in this one, 3y plus 2x equals negative 9. All right, with the same instructions. So let's see, we're going to subtract the 2x on both sides. And then I'm going to divide individually by 3. So this will be negative 2/3 x minus 3. And so I'm going to pick x values that are divisible by 3. So negative 3, 0, and 3. And let's see, negative 2/3 times negative 3 minus 3. So that's going to be positive 2 minus 3 is negative 1. The 0 is just going to give us negative 3. And then the positive 3, what are we going to get here? That's going to be negative 2 minus 3, negative 5. All right, so there's our points. Let's see what they look like. All right, let's see. Negative 3, negative 1, 0, negative 3, and 3, negative 5. And that's a pretty good straight line right there. And there it is. Okay? And it is always good, like I said, to label your scale just so that we have an idea for what those tick marks represent. Okay, and we got one more question on that last assignment that I just posted about x and y intercepts. And on this one, we don't need to graph it. We're just going to be finding the x and y intercepts. So problem 16, we've got 5x minus 4y equals 20. And we need to find the x and y intercepts. So remember, for the x-intercept, that's where y equals 0. So this will be 5x minus 4 times 0 equals 20. 5x equals 20. X equals 4. And so the point we're interested in is the point 4, 0. The y-intercept, that's where x is 0. So we plug in the 0 for x. Then we get negative 4y equals 20. Divide on both sides by negative 4. Y is negative 5. And so that makes our y-intercept the point 0, negative 5. Okay, so that's it for the midterm. That's all you'll see on the test. Let's see, don't forget you can bring a 3x5 note card with you. You can write anything you'd like on the front or back. Don't forget to bring paper, pen or pencil, and a calculator of your own. And as always, if you have any questions before the test, please let me know.